So when I take the integral, it looked like that. And now I'm going to plug back in my u substitution. So it will looks like this. And now I'm going to distribute, because here's why. Here's a little twist. So we did an aerial with a twist. Oh, we did calculus with a twist. Imagine that. Is that -1 is technically part of the constant collection. And so it would go with the other constant, which means it's really going to simplify. Remember, I can't distribute that 2 because that x plus 1 is really supposed to be under a square root symbol, right? But when I put that -1 and the c together, I just get another constant. So my final answer, and this would be a multiple choice type question, quite possibly. Final answer is that. Ooh, that was pretty arduous. You should go back and rewatch that video again to check and double check and triple check every step. And then you should cover it up and try to do it yourself on another piece of paper. So on number 3, notice now the difference is we're doing a definite integral. So we have numbers on top and bottom. And again, a new twist, but it's going to start out just like the others. I need to do a u substitution if I can find any of those specialties that I listed at the beginning of this video set. So of course I notice I have a quantity raised to a power, so I'm going to let u equal that quantity, and then when I take the derivative of it, I get 2x dx. And then I check to see if I have any of that, and I say, ah man, so close. I have the x, but I need a 2 with it. So no worries, and then there's the dx piece. I can accommodate having that 2 if I multiply by a half in front. So now the new integral is going to say 1/2, and then this blue quantity is, remember now it's u cubed, and then everything I underlined in orange turns into a du. So now here's the twist. I can integrate this and then plug back in x squared and leave the bounds as they are. But I can only use these bounds if I'm evaluating with x. And when I finish integrating, it's going to have a u in it. As a matter of fact, let's integrate this bad boy. So I'll have 1/2 u to the 4th over 4, remember plus c, or 1/8 u to the 4th plus c. And then I put my bar and put my numbers. But if I don't want to put the x back in, and I can do it either way, then I have to change those boundaries. And so here's how I do it. Of course, these are both x values. So I keep a little list over here. If x equals -1, that is a negative, then u will equal 2. And I'll do the top boundary. If x equals 1, then u also equals 2. And so these boundaries now go from 2 to 2. And remember, when I'm evaluating the definite integral, I don't have to write the plus c because it's going to cancel out at the end anyways. And of course I note, hey, I can't have an area if I start at 2 and end at 2, there's no width. So I already know before I plug those in, the answer, that is a 2 by the way, the answer is going to be 0.